Good day yet again, ladies and gentlemen, and welcome back. So today I want us to look at another question paper attack. This one I sourced from the February March exam of 2015. And yes, what we're looking at in this one is yet again work, energy, and power, which is question 5. Okay, now they say to me, a 5 kg block is released from rest, right? So when the moment you see such things, guys, remember I always say collect all your information, right? So from the information that they're giving me, they are saying it's released from rest. That tells me that the initial velocity is equal to 0 meters per second, right? Okay, and from a height of 5 meters, so the initial height is 5 meters. Why do I say the initial height? Because I know for sure this object is gonna move down and then eventually move in that direction, then eventually move up. Okay, so the initial height was 5 meters. Okay, and then what else do they say? It slides down a frictionless inclines from to point P. So in this point here, we do not have any frictional force, right? Because it's frictionless. Right, it then moves along a frictionless horizontal surface. So from P to Q yet again, the frictional force here is 0 newtons. Okay, and it finally moves from point P to point R. So in this case, from point P to point R, right? There is a rough incline. So we have a value of friction here that is unknown. Okay, right. So, and then they say it comes to a stop at point R. So at point R, the final velocity here is 0. Okay, now let's take data for different parts of this diagram. I think that's better. So this one here is from the starting position. I'm just going to say start to the point P, right? So it's from the starting position to the point P. Okay, where we have the initial velocity here, which is equivalent to 0, and the final velocity at point P, we do not assume that it's 0, we just don't know what it is, right? We don't know the velocity at P. Do not assume that it's 0, guys, please. What else do we have from P to Q? I mean, from the start to P, we do not have anything else. Okay, now we move to data from P to Q. So now the data that I have is going to be from P to Q. And then all that they tell me is that there is no friction. That's all that they're telling me. Okay, so we don't know the initial velocity, and we also don't know the final velocity. Remember, the initial velocity is the velocity at P. The final velocity is typically the velocity at Q. Okay, then we take data for the last part. So for the last part, what you'd notice is that that's from Q to R. So we know that at point Q, no, sorry. So from Q to R, we don't have any initial velocity. We don't know what it is. But we do know that at R, which is the final velocity, they said to us it comes to a stop. So the final velocity is 0. So here the final velocity is then going to be 0 meters per second. And at that point, what else are we told? We are told that there is a certain value for friction that is unknown in this case. But if you think about it, the final velocity would obviously, the initial velocity is at Q, and the final velocity is at R. So it's very important to denote such things. So this is my data for the entire question. Okay, so I'm gonna use this data on different parts of this question as I answer them. Now, sorry, I just forgot to mention that from Q to R, they gave me a height of 3 meters. So from Q to R, the final height is 3 meters. Why do I say that's the final height? Because the initial height is at point Q and the final height is at point R, and that's the 3 meters that we have there. Okay. Okay. Um, that's what we have now. Now they say to me, oh no, they actually gave me a value. Oh, I just rushed for this one. The frictional force, which is a non-conservative force, like we all know by now, between the surface and the blocks is 18 newtons. So where do we have friction? We have friction from Q to R, and they tell us that that friction is 18 newtons. So now we have a value, sorry. So let's remove this. Got this value as 18 newtons. Okay. Um, let's quickly confirm that we read everything correctly. So release from rest down a frictionless incline from P to Q. So we know that from the start all the way to P, we don't have any friction. Right, and then it moves along a frictionless. We yet again from P to Q, the friction is 0. However, from Q to R, the friction is 18 newtons. Okay, now they want the speed. So they say to me 5.1 using energy principles only, guys. Don't use anything else besides what they're asking you to use. Calculate the speed of the block at point P. Obviously, now you're going to look at the motion from the start to point P. So this is the data that you're going to look at, right? I hope you guys are seeing how helpful this is. So I'm then going to say, from the information that I have, what can I do? Oh yes, please realize that at point P, the final height is actually equal to 0 because that's literally at the flat part of this whole entire diagram. So the final height is 0. Okay. So this height here is the height at P. Okay, so now I have the initial velocity. I want the final velocity. I have the final height and I have the initial height. So which equation can I use here, ladies and gentlemen? Now we need to be smart about it. Now there are many equations, energy principles that you can use at this point. But which one would work best? Well, what you can use in this case, notice you have the initial velocity, you want the final, you have the initial height, you also have the final height. So you can use the principle of conservation of mechanical energy. That can also work here. So what I'm going to say is, according to the principle of mechanical energy conservation, it says that the mechanical energy in the beginning or initial is equivalent to the mechanical energy after or final. So this means that we're going to be looking at the kinetic energy plus the potential energy in the beginning. So that's initial, and that's going to be equal to the kinetic energy plus the potential energy final. Right, so in this case, what we would have here is, what is the kinetic energy value? That's 1/2 times the mass. In this case, guys, please pay attention. We are going to be using the initial velocity because we're looking at things that are initial, and that's squared, plus the mass times the value of g times the initial height. It's then going to be equal to 1/2 times the mass times the final velocity plus mg times the final height. So in this case, we know that we have the value of m. The mass of this object is 5 kilograms. So we have a 5 kilogram object. And the initial velocity, remember, we have it from P to Q. That's 0. 0 right there. So that's 0 multiplied by, remember, that's 0 squared plus the mass of 50 times 9.8, right? Times the initial height, which is 5 meters. Remember, all this information I'm getting from the data that I collected. All right, and then this is then going to be equal to 1/2 times the mass of 50 times the final velocity that we want, plus this is 50 times 9.8 times the final height of 0. So notice that on this side, the final answer is 0 plus 50 times 5 times 9.8, I get a value of 2,450. That's equal to 1 over 2 times 50. This is basically a half times 50, which is basically 25. So I can simplify that and say this is 25 times the final velocity squared plus 0. So I can divide both sides by 25 to make Vf the subject of the formula. So I'm going to get Vf squared equals to 98, right? And then I get the square of that. Therefore, the final velocity is equivalent to the square root of 98, and that gives me a value of 9.899. So to two decimal places, the final velocity is basically 9.90 meters per second. And what did the question say? They wanted the speed, so don't need a direction. So then conclude that therefore the speed at P equals to 9.90 meters per second. Right, for those that are attempting this question, which I hope we all are, I do believe, or in fact, I do hope you guys got exactly the same answer as mine. Okay, right, so moving on. Now they say 5.2, explain why the kinetic energy at P is the same as the kinetic energy at F. Oh, okay. I mean, if you think about it, guys, this is before I go on, in 5.1, someone else, remember guys, we have more than one energy principle. Someone else might have decided to use which other one can you use here? The work done by or the work energy theorem, right? Or you could have used the work done by a non-conservative force. You could have used different types of forces here. I mean, different types of equation. If you use the work energy theorem, you'd find that in the work energy theorem, we're saying that W net equals to the change in kinetic energy, right? And okay, would this have worked? Okay, we know that W net would be, okay, no, this wouldn't have worked necessarily. But what could have worked definitely is the work done by a non-conservative force. Because from here, this is the sum of the kinetic energy plus the potential energy. And from here, you know that the work done by a non-conservative force, in this case, would be friction or tension or applied force, but we don't have kinetic energy. Sorry, we don't have applied force because the object is sliding on its own. We don't have the applied force. We don't have a tension force. We don't have a frictional force. In fact, we've already established that. Therefore, the work done by a non-conservative force here would be zero because we don't have any conservative forces. And then from here, you can then solve and get the value for your height. I believe you should get to the same answer. You can also attempt that on your side and then post your answer on the comment section if it's different perhaps for some reason. Okay, so 5.2, they say to us, explain why the kinetic energy at P is the same as Q. So if you think about it, guys, at P, what's the height at P, guys? Notice something that the height at P is equivalent to 0, right? And the height at Q is also equal to 0. But now the question is why they asking about the, so the question is why is the kinetic energy at P equal to the kinetic energy at Q? Now you then ask yourself, according to the equation of kinetic energy, we say that it's equivalent to half the mass times the velocity, right? Now, think about it. If you have a certain velocity at point P, right? Whatever the velocity at P you would have is would obviously not be the same as the velocity at Q. I mean, it would differ in a way, but it's not a conclusion that we can just rush to make, right? But we need to think about it more intuitively. Now, from P to Q, remember what we established here. This is what we have at P to Q. We know that from P to Q, the frictional force is equivalent to 0. So the frictional force is the same, right? So you then ask yourself, guys, what are all the forces that are acting on this object from P to Q? What are all the forces acting on the object from P to Q? Of course, there are no other forces acting on this object except for frictional force. So if frictional force is equivalent to 0, if you think about it, the equation W net equals to the change in kinetic energy. And W net is equivalent to F net times delta X times cosine of theta. We know that kinetic energy at this point, the change in kinetic energy would be equal to 0. Why? Because all the forces acting on the object from P to Q are only the kinetic frictional force. And what's the value of the kinetic frictional force from P to Q? It's 0. So I put in my 0 there. Whatever delta X is and whatever cosine of theta is, this is going to be equal to delta EK. So if this is 0, then the whole thing is 0 and delta EK will then be 0. So the change in kinetic energy from point P to point Q will then be equal to 0 joules. Hence, the kinetic energy from P will definitely be equal to the kinetic energy from the kinetic energy at P would then be equal to the kinetic energy at Q. So in this case, if you think about it, if you find out, in order for you to write this in a proper way to explain your answer, you would then say, since um, the frictional force from P to Q is equivalent to 0. That means that the net force is equivalent to 0. And as a result, there is no energy that is lost from the during the motion of the object from point P to point Q, right? Similarly, this is what you could also say uh, would be different to what I'm saying right now. Remember, guys, the way we give answers, especially in physics and chemistry, we explain answers. We are not all going to write the same answer. But whatever we answer must somehow boil down to the same idea. We need to all have the same, reach the same conclusion. We must all stick to a single point. Although we structure our answers differently, all our answers must have the same idea. Okay, so how I would have typically answered this would be to tell them that the reason why the kinetic energy is the same is because during the motion of the object from P to Q, the kinetic energy, the frictional force is 0, right? And as a result, the net force becomes 0 as well. And that tells me that there is no loss in the energy during the motion of the object from P to Q, right? So what you need to mention, what the key points there would be, is that the kinetic energy is 0, right? And obviously, if the kinetic energy, why do I keep saying kinetic energy? Sorry. We know what the key point there is for you to say that the frictional force is 0, and as a result, that would make the net force equivalent to 0, and as a result, there is no energy that is lost during the motion from P to Q. So that's the point that you needed to focus on the most. Although we would answer this question differently, we need to have the same idea in our answers. All right, so 5.3 then says define the term non-conservative force. You know the definition. The work done in moving an object from A to B that is dependent on the path taken. Now the last question says, calculate the value of theta. Now, if you think about it, guys, theta is this angle here, right? That's the value of theta. Now, we need to now think about what we can do. We need to have a plan of attack. So we're looking at the data from Q to R now. We know that from Q to R, we have the initial velocity, the final velocity, the friction, and the final height. We also have the initial height, which is 0. So at Q, the initial height is 0. So let's just add that as well. The initial height is 0 meters. That's at point Q, right? Cool. So from the given information, what my plan of attack is, we can try and work this thing out and in a way try and solve for what? Use an equation that will allow me to solve for the displacement from Q to R. right? That allow me to work and solve for delta x. And from there, to get the value of theta, I can use any trig ratio that will allow me to get the value of theta. You can use sine, which would be opposite over hypotenuse, best one to use, or you can use, okay, I wouldn't recommend that you use the tangent or the cosine, so just stick to the sine. So I need to first get the displacement, then use a trig ratio sine to solve for the value of theta. So that's my plan of attack. So let's implement the plan of attack. So where do I start? I need to start by determining the delta x. So the first thing that I need to do is look at the information that I'm given and then work on a way out. So guys, think about it. Remember, we don't know what the velocity at q is. So we don't have the initial velocity at point q. So how can we get that initial velocity at point q? Now, it is very important that you understand what this question was basically trying to do for you, right? It's very important for you to do that. Now, they say to us that the kinetic energy at point P is the same as the kinetic energy at point Q. So in this case, I want you to think about it. Let's get the kinetic energy at point P and let's see what we have. So the kinetic energy at P is equivalent to 1 over 2 times the mass of the object at point P times the velocity at point P. And this is going to be 1 over 2 times 50, that's the mass of the object, times the velocity at point P. I think we got that as 9.90. So that's going to be 9.90. As a result, this becomes 1 over 2 times 9.90 times 50, and that gives me a value of 247.5. So that is the kinetic energy at point P. And remember, now we know that the kinetic energy at point P is the same because of this statement here. So now we can say, okay, I'm not done, just make joules. Now from here, I can then say, since the kinetic energy, guys, of P is equivalent to the kinetic energy at point Q. That means that the kinetic energy at point Q, which is equivalent to half the mass times the velocity at Q, is going to be equal to 247.5, which is equivalent to 1 over 2 times the mass of 50 times the velocity at Q, which is what we want. And from there, if I divide everything, 50 divided by 2 is 25, so I'm basically going to divide everything by 25. So this would cancel that, and we would then have the velocity at point Q would be equal to 247.5 divided by 25. And that should give me an answer of 9.9 meters per second. So that's the velocity of the ball at point Q. Now I can update my data. Remember, this was the velocity at Q. So instead of putting in a question mark there, I can just say now I know the velocity initial is 9.9. Now I can then use an equation that's going to allow me to substitute everything here. Which equation is that? Work done by a non-conservative force. So I can then say now that the work done by a non-conservative force is equivalent to the change in the kinetic energy plus the change in the potential energy. So in this case, this is then going to be what? How many forces are acting on this object from Q to R? Remember, that's only the frictional force. Is frictional force a non-conservative force? Yes. So when I need to expand W and C, I can say this is the work done by friction times delta X times the cosine of theta. Why am I saying Fk? Because this is the only force that's acting on the object that is considered to be a non-conservative force. Or said differently, Fk is the only non-conservative force acting on the object from point Q to point R. Right. So from here, I can then say, if I further simplify this, this is 1 over 2m v final squared minus v initial squared. I hope you all know how I'm doing this. If you don't, please make sure to go and watch the previous videos minus the final height. Okay, so the frictional force from point R to Q, or from Q to R, was found to be 18. So this is 18. Remember, this is frictional force. We don't have delta X. That's actually what I want. And we know this is friction and it does negative work. Guys, what did we say? When something does negative work, when a force does negative work, then what's the value of theta? 180. Yes. So this is then going to be equal to 1 over 2 times the mass, which is 50. Open the bracket. The final velocity is at point R, and we said that's 0. The initial velocity is 9.9. So this is then going to be equal to 0 squared minus 9.9 squared plus the mass of 50 times 9.8, open bracket, the final height. Remember, we have this in our data. The final height is 3, the initial height is 0. So this is then going to be the final height of 3 minus the initial height of 0. And what I would have on this side would be 25 times, so let's see, this is 0 squared minus 9.9 squared. This gives me a value of negative 98.01 plus 50 times 9.8 times 3 minus 0. That gives me a value of 1470. And on this side here, this is going to give me negative 18 delta x. How did I get that? Remember that cosine of 180 is negative 1, so negative 1 times 18 is negative 18. Cool. So from here I can then say negative 18 delta x equals to, on the right hand side, I'm going to have 25 times negative 98.01 plus 1470. That gives me a value of negative 980.25. So I divide both sides by negative 18, divide both sides by negative 18. Delta x in this case will then be, my answer that I got divided by negative 18, I get my displacement to be 54.46, round to 2 decimal places. Okay, 54.46 meters. Now guys, I have gotten the value of delta x. Now I can use my trig ratio, right? Now I can say, to get the value of theta, I can say sine of theta is equivalent to the, is opposite of a hypotenuse, where the opposite is the height and the hypotenuse is the delta x. So this is then going to be sine of theta equals to the height, which was 3, and delta x is 54.46. So to get the value of theta, I then say this is arcsine of 3 divided by 54.46, and I get the value of theta to be arcsine of 3 over 54.46. I get a value of, okay, the value that I'm getting here on my calculator is quite weird. I feel like I've made a mistake somewhere that I need to fix before I move on. There must have been a mistake that I've made, so let me just quickly confirm here. Um, So let's see, what did I do? Maybe there was a blunder in my calculations here. Let me quickly just put in, I want to put in this part in the calculator again and see. So this is 1 over 2 times 50, right? Times 0 squared minus 9.9 squared, right? Plus 50 times 9.8 times 3. The value that I get is negative 980.25. Okay, that's okay. When I divide 980.25 by 18, I do get 54.46. Okay, so I trying to find the fault in this. Um, oh yes, there it is. Um, if you guys notice here, the mass that I substituted here was 50. I don't know where I got 50 from. The mass is actually supposed to be 5. There it is right there. Makes sense. Because I'm actually getting an angle of theta as 0.03 something, and that's way too small for an angle theta, considering that we have a right angle triangle there. So that won't work. So now I need to fix my error, and yeah, that's the only issue that I'm seeing right now. So the mass here is supposed to be 5 actually. So sorry guys, I'm pretty sure you guys actually saw this and were like, oh no, how do we tell him? You can't tell him. If you tell him, he won't hear us. Oh gosh. Okay, so let me just fix my answers here. So now this whole thing is wrong. Eesh. See, sometimes guys, it's very important for your answers to make sense to you as an individual, you know? So just put that in the calculator yet again, 1 over 2 times 5. I feel like I use the same mass everywhere else. Oh gosh, I use the same mass here as well. I use 50. Let's see what it would have been if I used a different answer. If I used 5, I feel like my answer now is, see, one mistake literally kills everything, guys. So this is 5 times 9.90. So the velocity of p is 9.90. Um, and I get a kinetic energy of 24.75. 24.75 joules. And then same thing here. This is definitely not the velocity that we're looking at. So this is 1.2. Okay, this is also going to be wrong, of course, because it affects everything else. I'm fixing my errors here, guys. I can't believe I made so many errors. So this is 24.75. Then the mass is 5, and then the velocity of q is what we want. Then I divide by I multiply both sides. Okay, let's just do some maths here. So in order for me to do this, I'm just gonna multiply both sides by 2 over 5, and then multiply here by 2 over 5 again. So this cancels that, this cancels that. So the velocity of q is 2 times, sorry, it's 2 over 5 times 24.75, and I get a value of 9.9. Oh, okay. Surprisingly, the value is still the same. It didn't really change anything. So the velocity at q is 9.9 meters per second. And it was a bit unnecessary for me to do this whole EK calculation, because if we say that the kinetic energy at P is equivalent to the kinetic energy at Q, given that the mass remains the same, the velocities would also be the same, if you think about it. So this was necessary. That's why you've noticed that the values of the velocities are the same at the end of the day. Okay, now let's quickly fix our blue writing error here. So I substitute 5 there. This is 0 squared minus 9.9 squared. Okay, I get a value of negative 245.025. Plus, and then on this side it's 5 times 9.8 times 3, which gives me a value of 147. So negative 245.025 plus 147 gives me a value of negative 98.025. and I divide that by negative 18, I should get the answer divided by negative 18. I should get that as 5.45 meters to two decimal places. But because this is not the final answer, I'm just going to make it 3 decimal places at least. So this is 5.446 meters. So I then substitute that here and get 5.446. Therefore, theta is equal to arcsine of 3 divided to 5.446. And I get the value of theta as arcsine of 3 divided by 5.446, and I get a value of 3, arcsine of 3 divided by 5.446, and I get a value of 0. Why is my theta so small? Why do I feel that? What else am I doing wrong at this point? I feel like there's something that I'm doing wrong. Oh yes, sorry, my calculator, guys, is in radians. My answer is actually correct. It says my calculator is in radians. You know, that's a format that you can do in your calculator that usually works when you're dealing with your angles like 180, 90 degrees, you know, on trig function. Yes. I was using radians when I was doing this my own work here. So I don't use angles as 45, I use them as radians. Sorry, let me just convert this back to what it was before. Yeah, there we go, back to normal. So this is arcsine of 3 divided by 5.446, and I get a value of 33.43 degrees. Now that's my final answer. Now this one makes sense. Right. I hope everything was fine besides whole errors that I've made there and there, assuming that the mass was 50. But apart from everything else, I hope everything was clear. That then brings us to the end of this question. I will see you guys in the next video. Goodbye.